All right. Hello, Year 9s. We're going to go through this cone example. This first video, we're going to go through a slightly longer method. There is a faster method than this one, but I think it's nice just to see different types of methods and to see the logic behind how we can find the volume of this cone. So right now we know the radius of this cone is 2 meters. The volume we don't know. The radius of this bigger cone is 5 meters. The volume we still don't know. But sometimes it's nice to summarize the things that we do know. So we can see these are already summarized, volume, radius. But the extra little bit of information that's kind of hidden here is that the length scale, it is a 2:5 ratio of the length scale. 2 meters over here results with 5 meters over here. And the next thing we want to do is figure out, well, what do we need to know? We're trying to find the volume. Well, one method is to say to ourselves, well, if I knew the height of this smaller cone, I could use my volume formula. My volume formula says the area of the base times the height divided by 3. So the area of the base times height divided by 3. That is the formula for the volume of a cone. But unfortunately, there's too much unknown over here. But if I could figure out somehow, figure out the height of this bigger cone, then I could use my length scale to say, well, if this height was, 10, I could use my length scale to figure out that this height would have to be 4. So if we can somehow figure out the height of this cone, we can solve this problem. And luckily, we do have enough information over here that we can actually start solving for the height of this big cone. So remind ourselves, volume equals area of the base times the height divided by 3. So that means, in this case, area of the base, the area of this base here, is going to be radius times pi. So 5 times, I can just write my squared. 5 squared times pi. So r squared times pi gives me the area of this base. Multiply this times the height, which we don't know. Divide all of that by 3. And when I do this, what should this all be equal to? Well, we know the volume is supposed to be 8,000, so this calculation, all of this should end up equaling 8,000. So now we have an equation here that we can actually solve to figure out what the height is. And I should probably use a calculator so I don't mess this up. But let's try. We'll do this first. 5 times 5 times pi. 5 times 5 times pi is approximately 78.54. So that's the area of this circle base, times the height, which we don't know, divided by 3 should be 8,000. Now we're going to continue trying to solve this equation. The opposite of dividing by 3 is multiplying by 3. So over here I'll still have 78.54 times the height equals 8,000 times 3 gives me 24,000. And now to actually solve for h, I'm going to divide both sides by 78.54. So 24,000 divided by 78.54. That gives me 305.58. We'll round that to 58 meters. And I know it's meters because these units are in meters. These units are, everything's in meters, right? The length is meters, the volume is meters cubed, so this must also be in meters. So great. We now know the height of this, no more question mark here, the height of this is 305.58 meters. Perfect. Now that I know the height of this, and I know the length scale is 2 to 5, we can figure out the height of that smaller cone. So this is the height, we can even label that height of big cone. Now, one thing I like to do, just for my own, ability to understand these questions, 2 to 5, this is the correct way to write this ratio because it's in lowest reduced form. But I like to think about what what is just 1 unit worth on this side? So if the length scale, it's a 2 to 5. Well, that's the same. If 2 gives me 5 meters, then 1 meter on the small side would give me 2.5 meters on the larger side. And we know we don't want decimals. This is not the correct way to write that ratio. If I was to ask you to write the length scale, that's not the correct way to do it. We don't want decimals. But in terms of solving the problem, I think it's nice to think about, okay, well, what's just 1 worth? So what this means is every 2.5 meters on this side results in just 1 meter on this side. So I have to figure out how many 2.5s fit into this length here. So how many 2.5s fit into here, and that'll tell me how many meters I have over on this side. So we'll do 305.58 divided by 2.5. 305.58 divided by 2.5. That gives me 122.232 meters. So the height of small cone is 122.232 meters. So these are important pieces of information. Now that I have this, I can do the final step. I've got the radius of the circle. I've got the height of the cone now is 122.232. So this is 122.232. So now I can do this final step of actually finding the volume. So maybe let's get rid of this for right now. But volume of small cone. So we're going to take the area of the base, which is radius squared times height. Or sorry, radius squared times pi. That gives me the area of the base. Times the height divided by 3. So radius is 2, so we get 2 squared times pi times the height is 122.232. And all of that will divide by 3. And I'm kind of running out of space, so we'll just do this all in the calculator at once. I'm going to punch all this in the calculator. So 2 times 2 is 4 times, using my pi button. So the area of this circle ends up being 12.57 meters squared. I'm going to take this answer times the height. The height is 122.232 meters. And that answer, I get 1,536.01. And I'm just going to take this, keep this all in my calculator, and divide by 3. And I get my final answer is approximately 512.004. So I'm just going to leave it at 512.00. There's a bunch of extra decimals, but if we're rounding, we'll just leave it at approximately 512 meters. So we'll just say the small cone has a volume of 512 meters. And I know this is a little bit messy, but hopefully someone could follow these steps along. This is step 1, which leads to step 2, which leads us over here to step 3. All right, so that is the longer method, but hopefully it makes sense how we found this height, used our length scale to find this height, and then once we had all that information, we could find the volume of that small cone. In the next video, we're going to show there is a much faster way to solve this problem.